All right. So as we were saying, base quantity in physics or base quantities are the fundamental physical quantities that are defined independently and can be expressed in terms of other quantities. Okay, if we say they are physical quantities, yes, it's true. Time is a physical quantity that at the end of the day we experience each and every day. Okay, yes, mass, the weight of an object. You see that at the end of the day, mass, okay, is something we also experience in our daily life and all that. Okay, yes, independently means they work on their own and expressed in terms of other quantities. It means that when you take derived quantities, a combination of two or more base quantities actually what provide a what derived quantity. Do you understand me? Okay. So the form base quantities form the foundation of measurements. Okay, in science, particularly in the international system of SI units. Okay, good. All other physical quantities called derived quantities are built from these base quantities. Take note that base quantities in some cases can also be called the fundamental quantities. And here are the 7 SI base quantities. Okay, please take note of this very well. Anytime you provide an answer without a unit, it's considered wrong because we don't actually know what you are talking about. Okay, good. So that is why at the end of the day, you always see length being measured in meters. Okay, but before we even come to that, let's take time and dissolve this one after the other. Good. This is a table 1.1, and this is a basic quantity in the SI metric unit system. Okay, good. In the SI metric unit system. So over here we have our quantity, over here is our SI unit, and over here is other metric units. Okay, good. So our length is measured in meters, and time is measured in seconds. Force is measured in Newton. Mass is measured in kilogram. Also, temperature is measured in Kelvin, and angle is measured in radian. 1, 2, 3, 4, 5, 6. Okay, good. In actual fact, or for beginners, we always start with 7. Okay, one has been removed over here, and it has been removed because at the end of the day, we are not going to be using it in this particular course. Okay, good. So let's say at the end of the day, we are beginning with 6. Okay, so these are the main ones you should focus on. Okay, for this course. And this is 1, length, time, force, mass, temperature, and what? Angle. If you are being asked to calculate for the length of an object, and you go and take your tape measure and you measure and you write, or maybe you do from calculations and you provide the answer, let's say you had 3 meters, and at the end of the day, you just write 3 and you leave your answer. Like, you'll be marked wrong. You are supposed to write what? 3 meters. Okay, because length is measured in what? Meters. Okay, good. Remember that time is also measured in seconds. So anytime you are calculating for time, your answer, you are supposed to write it in what? Seconds. Okay, your units, you are supposed to add your unit to your answer. If you fail to add a unit to your answer, at the end of the day, you're going to be penalized. We said force is equal to what? Mass times acceleration due to gravity. Okay, so that is mass times what? Acceleration. Good. At the end of the day, if you have your answer, okay, and you don't express it in a form of Newton, it is wrong. Okay, so let's say a body of let's say a body of mass 50 kg. Okay, good. Is accelerated. Okay, it's accelerated by an external body. So let's say the mass is 50 kg. Good. And the body is accelerated. Okay, yes, by another body at a speed of what? Let's say 3 meters per second squared. Okay, because acceleration is measured in what? Meters per second squared. You can see that I'm adding the unit too. Good. So at the end of the day, if you are supposed to calculate for your force, what do you think is going to be? You are going to multiply the 50 times the 3. So at the end of the day, 50 times 3, what are you going to get? You are going to get, what are you going to get? Hello?
150,
150
please.
meters squared.
All right, all right, all right. So you're going to get 150.
150 meters squared. Okay.
No, it's not 150 meters squared though. This is multiplication. So it's going to become what? 150. And if you leave your answer like this, it's wrong. It's either you're writing 150 Newton or your answer should be such that 150 kg, okay, dot. Dot means multiplication, okay, good, meters per seconds squared, okay. It's either you are choosing to bring this bar over here like this, and at the end of the day, this will not be here, or the other way round, okay. I always prefer the other way around because that looks, or that tells an examiner that no, this guy is well learned. Okay, so I like it this way. So you see, if you don't provide a unit at the end of the day, whatever you are doing is actually totally wrong. Okay, that is why over here you are seeing over here we have what force being measured in kg meters per seconds squared. All right, all right, all right. As you are seeing, mass is also measured in kilogram. Temperature is measured in Kelvin, and then the angle is measured in radian. Take note that mass can be measured, or the mass of an object can be obtained with a what? Either a chemical balance, a beam balance, or what? An electronic balance. Okay. Also, the temperature of a body can be determined by either a thermometer, etc., etc., etc. Okay. Yes. So I'm sure we have all read angles before. You can read angle with, let me say, a protractor. Do anyone know a protractor? Yes, I'm sure we have all seen it in our math sets before. So that is it. So at the end of the day, let's all remember to always add our units to our work. Other than that, whatever suffered you have suffered is just going to be in vain. Okay. On this note, I want to say that the laws of physics are the same for all observers in uniform motion relative to what? One another. This means that someone is reading electrical engineering, someone is reading building technology, someone is reading civil engineering. At the end of the day, physics is found in all these aspects because you realize that physics has so many branches. Good. At the end of the day, you realize that no matter how we are all applying the laws, the units should always speak the truth. Do you understand me? So if you're applying the law anyhow, and at the end of the day, the unit does not look like the original one, then you should know that there is a problem with your work. Do you understand me? So the units are what always tell the scientists, or let me say physicists, the truth. Okay, so I believe in units a lot. Yes. All right. So let's proceed. Let's proceed. So these are some keynotes you can jot down. You can jot down. These quantities are independent. For example, time cannot be defined in terms of mass or length. As you are saying, time cannot be defined in terms of mass or length. All right. Let's all take note that derived quantities, which I said they are the combination of two or more base quantity. And as an example of a derived quantity can be what? Velocity, let's say pressure, energy, and then the rest. Because at the end of the day, the combination of these two or more base quantities are going to provide this, or some of these quantities to us. Okay, good. Take note that, please take note. Please take note that force over here. Can we all see force over here? This force over here is a derived quantity. Apart from that, you can call length, time, mass, and temperature a what? A base quantity. Okay, good. Because at the end of the day, you realize that this what? Kilogram is kg. Have to multiply what? Uh, acceleration. Okay, and acceleration is also what? Change in velocity over what? Time. Okay, that is the change in velocity over time. What is the meaning of the velocity too? The velocity also is equal to what? Change in what? Displacement over what? Time. And that displacement is measured in what? Distance, meters. Okay, good. So at the end of the day, uh, as simple as that. Okay, but the difference is that velocity is measured in meters per seconds, and acceleration is measured in what? Meters per second squared. So at the end of the day, the unit of velocity is given as what? Meters per seconds. But acceleration is written as what? Meters per seconds squared. Okay. So at the end of the day, you can see that the meters is a base quantity. The S, which is time, is also a what? A base quantity. So the combination of the two is giving us a what? A derived quantity. A is also a derived quantity, but this is not our main focus. Okay. So let's proceed. Example, velocity is equal to what? Length divided by time, as I just discussed to you, and as I told you, force is also equal to mass times acceleration. Okay, good. Please, at this point, I want to take some few questions. Do anyone has any question to ask before we proceed? Do anyone have any question to ask before we proceed? All right. If no question, then let's quickly proceed. Let's continue to talk about the SI prefixes, the most important of all. The most important of all. Good. The SI prefixes, also called metric prefixes, are symbols added to unit to indicate multiples or fraction of those units. They make very large or very small numbers easier to read and work with. For example, instead of writing, let's say, this is how many zeros? 1, 2, 3, 4, 5, 6. So 60, okay? So this can be written as what? 1 times 10 negative 6, right? Good. But in the other way around, what do you realize? You realize that if we are doing some big calculations, and at the end of the day, what is this going to give you? What is 1 times 10 exponent this going to give you? Someone should quickly work this out and give me the answer. You realize that at the end of the day, it's still going to give you the same thing, okay? And this can be expressed as what? 0.00012123456. 6 zeros because there is 6 on top of what? The 10. But because it is a negative 6, it means that I have to bring 6 zeros, and then after the first zero, I put a point. Okay. Then at the end of the day, I can now bring my what? 1. Do you understand me? And that is termed as what? Micrometer. Some people will call it the mu. I'm sure you have all seen the mu in the SI prefixes before. That is it over here. You see. So this is an example of a symbol that scientists can kill you with in questions. Okay, they can give you a very simple question which you can solve, but once they put some of these symbols in it, if you don't know the meaning of these symbols, you can never be able to solve the question. Okay, so first of all, you have to hack this system. Once you hack the system, you are good to go. Okay, there are so many ways of killing a cat. I'm going to give you my way of killing it. I wish you can also be able to what? Derive more other ways of doing that. Okay, and that is going to make you more creative. Good. So some examples of the SI prefixes I'm talking about is we have kilo, mega, giga, and then the rest. Okay. To avoid playing about the bush, kindly look at what I'm having over here. And here is a structural list of most common SI prefixes, okay, which especially we're going to be using in this semester. Not this semester alone. No. You actually need this until even you are done with engineering, okay? Because you're going to meet this in Form 1, Form 2, Form 3, okay? Even in your top up, you're going to meet this in level 100, level 200, level 300, level 400, and it continues like that, okay? So if you are not able to dissolve this today, in future, it will haunt you, okay? Good. So let's proceed. So this, as we can see, this is our prefixes, these are the symbols, and these are the multiplication factor. The list of prefixes we have over here, let's all count it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As you can see, we have 12 number of prefixes over here. And it goes by the name tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, and pico. Knowing the names is also a very good thing, but the symbols is what is going to torment you more often, okay, or in most cases. So I will advise each and every one of you, it's good to know the names, but the symbols, take very good look at them, okay, because you're going to see them in questions. I'm sure you have started meeting some of them already, okay. Instead of writing a force as, let me say, 500, or let me say 5,000 Newton, it can be written as what? 5 kilo Newton. If you are solving and you forget to dissolve the K into 10 exponents, what? 3, and you don't know, you use the 5 to solve the work, whatever you have done is wrong. Meanwhile, you had the idea. That is why it is good to know some of all this. It's not K they always use. Sometimes they can put mega over there. If you don't know, you don't know. Okay. So the T means 10 exponent 12. The G is 10 exponent 9. It continues like that. What can you notice? When you start from what? Top to down, you realize that the numbers are decreasing, okay, by 3. Okay. But if you come and start from down to top, it is increasing by what? 3. You. So this over here we have just spoken about. I want to pick 1 or 2 questions from you. If you don't have any question, we proceed. Please, do anyone have any question before we proceed? All right, all right, all right. Since we don't have any question, let's proceed. Note that the use of the SI prefixes, hecto, deca, deci, and centi is not recommended in SI. Okay, good. In our next stage, we are going to look at how we can also draw the SI prefixes, okay, without looking on anything. Yes, this is the stage that we have gotten to now. So I want someone to quickly give me a summary of whatever we have been talking about since we begin. Can I get anyone to throw a little bit of light on that for me? Hello? Please, can anyone give me a summary of whatever I have just spoken about? Just a summary.
Right, I'm William. Good evening. So you spoke about SI units. I don't know the full meaning of SI, but I just know SI units, right?
All right.
Um, you said that these are basic units that we use as engineers across board, and that when you do your calculations, most of the time, whatever figure you get, if you don't put the units at the end of the figure, marks will be deducted. And for instance, wait, not a moment. Sorry. Hold on. I mean, my earpiece just fell out. So, for instance, let's just go on. So, for instance, you are doing your measurement length. Length is measured in meters, right? And
Yeah.
then you spoke about is it force? Force is mass times acceleration.
Good.
Am I still active online?
Yes, please.
Hello.
Yeah, hello, please. I'm
Very
listening.
well. So force is mass times acceleration, and so on and so forth. And then you also spoke about sometimes if um, you spoke about is it kilonewton? Yes. So mass is measured in newtons, right?
Mass is measured
And
in
sometimes
kilograms. Mass is
in
measured
kilograms. Sorry.
in inches.
Aha. It's measured in kilograms. And so um, we spoke about 10 raised to the power 12, which is tera. We spoke about 10 raised to the power 9, which is giga. We spoke about 10 raised to the power 6, which is mega. We spoke about 10 to the power 3, which is kilo. And hecto is raised to the power 2. Deca is raised to the power 1. Then when it comes to the minute numbers, when it is 10 to the power minus 1, it's deci. Then I think we spoke about 10 to the power minus 2, which is centi. And then 10 to the power 3, which is milli. and then 10 raised to the power minus 6. I hope I'm right. Sorry, micro, and so on and so forth. That is what I can remember so far. Thank you.
All right, all
My
right.
earpiece has fallen out, so I'm not able to. I'm sorry, forgive
Don't
me.
worry,
But
don't.
that's what I can
Really
I
try.
can recollect so far.
Let's all give him a round of applause. You really did very well, and I'm very glad. Anyone to also tell us something more or something different, or any addition, any contribution you wish to add up to whatever we have learned? Any contribution or addition? All right. So I continue to say that when you enter the examination hall, the first thing you should be able to do as a smart student is to what? Pull down the SI prefixes. Okay, it's your bread and butter. You will need it throughout your lifetime. Okay, so you're supposed to know how to be able to even come about with it. Okay, but it's not a problem, and I won't advise you to chew all of that in your head. Because of that, why I have found a very simple technique, which is a song we are going to learn now. With the help of the song, it's always going to help us to be able to remember all of these prefixes, so that no matter how scientists trick questions and they happen to appear in them, we don't shake much. You understand me? Okay, so this is the prefixes, and this is the song. Or let me even start with a song. Let me even start with a song. So this is our song. Yes. And this is the preface. And this is the preface. Also, this is our symbols. And this becomes our multiplication factor as usual. So this is the multiplication factor. Multiplication factor. Good, good, good. So we are going to just continue with the song right away, and life is going to be much more easier. In 4 minutes time, the link is going to go off. Please remember to click the link again and join so that we can come back stronger. All right. So it goes like this. We said that what? To Ghana, my kingdom, how that I do can make me not perform. Okay. So we say to, let's all sing together. To Ghana.
Ghana, my kingdom.
Yes. To Ghana, my kingdom,
How can I?
how that I do can make me not perform.
How did that do?
Ghana, my kingdom.
Ghana, my kingdom. How that I do can make me not perform.
Dada, the dada is confusing. I beg. Sorry. How dada?
Don't worry. Life shall be time. So how Dada do, you can even say that
How?
what you wish to do. But I'm saying Dada because of what? DA, Deca. You understand me? So once you see the DA, you go quick. All right. So how Dada do can make me not perform? I think we need more lines. More lines.
Make me not perform. Let's see.
Okay. How Dada do? They are saying make me not. Okay. So can make me not perform.
To Ghana, my kingdom, how that do can make me not perform?
So can make Mew not perform. So this is Mew not perform. Take note, intelligence is being able to adapt to what? Changes. When the drum beat changes, always remember to adapt the dance so that life always become much more easier for you. I continue to say that level 100 is the most easiest you can ever come across. So I will urge each and every one of us to put everything aside. You came individually and you believe in individually. If you are not able to make the grades now, in 200, you may not be able to make it. Build a GPA now. I have been to all those stages and I know what I'm telling you. And I know what I'm telling you. All right. All right. So burn more midnight candles. Allow mosquitoes to feed on you so that you can get more knowledge. That is the good way. Whatever way you choose to adapt, make sure that at the end of the day, it's going to bring success to you. I will advise you that focus more on your books. You came individually and you will be what? Living individually. If you follow friends, if you don't take time, it may be too late for you. Okay. So this becomes what? To Ghana, my kingdom, how Dada do can make Mew not perform. Can make Mew not perform. Okay. So how are we going to come with all the symbols? First of all, you have to remember to go and write the symbol first. And the symbol is going to help you even know the names. Okay. So good. From here, what are we supposed to do next? We can just start writing the symbols. Hello. Let's quickly sing the song one last more time again. To Ghana, my
To
kingdom,
Ghana,
To
my
Ghana, my
kingdom.
kingdom, how that do can make
you
you not perform?
You not perform.
good. So when you
To
say
Ghana, my.
it means what? Terra.
Terra,
It means E. Anywhere you see J, it means what? Giga.
Giga,
Anywhere you see M, it means it means what? Mega.
Mega.
You can see that the first three I started with what? Capital letters. To Ghana, my. Do you understand me? Good. Then from kingdom going, make sure you always smaller letters. Okay. Make sure you always use small letters so that at the end of the day, you can be precise in what you are doing. Good. So the kingdom becomes our what? Kilo. What else again?
Hector,
Oh, becomes our what? Hecto. So I just write,
Hector,
you see, Dada becomes our what? Deca.
Deca,
DA because I'm seeing Dada. DA. Good. Do becomes our what? Desi.
Desi,
And then the C becomes our centimeters.
Centi.
Good. The M becomes our milli. And then the mu. And the didn't know who say. If you hear mu, this
Mic-
is for mu.
Micro,
You see. Uh-huh. Then the knot becomes your what? Nano.
Nano,
The P becomes your pico. So that
Pico,
small p. This p over here is a very small p. Take note of that. As I said, it is only the first three that are capital letters. The rest are smaller letters. On this note, I continue to say that the laws of physics are the same for all observers in uniform motion relative to one another. No matter how you apply them, they should always speak the truth. But if you apply them and they don't speak the truth, then you realize that there is a problem. Okay? Yes. So at the end of the day,